Welcome back to another class of AI, machine learning, data science, and big data analytics. The topic of this class is going to be exploratory data analysis, which is also known as EDA. We're also going to cover things about data visualization with Matplotlib. Matplotlib is also another module or library by Python, which basically helps you to give you out a visual result. Let's say it could be like a chart, it could be like a coordination, it could also be like hot springs. Okay, so make sure not to skip any part of this class because I kept it super beginner friendly. I'm also going to give you out code examples. I'm also going to help you out with the explanations about the codes and also what is going to help you and how you're going to make sure to use the codes to make sure to get the full functionality of EDA, Python, and also Matplotlib. So without any further ado, let's open up PyCharm, and if you're not using PyCharm, open up any of the IDE that you are using. So, just as you can see, I have opened up PyCharm. Let's create a new project, and that is basically it, and press on create. So, just for waiting a couple of seconds, you will see that the virtual environment will be created. The first thing that we need to do in this class too is installing the modules. Now there are going to be two types of modules that we're going to need in this class. The first off is to validate the dataset or the data frame and also to visualize our data. So here I'm going to type in pip install pandas. Let's wait for a bit until pandas is successfully installed on our device. The next thing is to visualize our data, which is Matplotlib. So we're also going to make sure to install Matplotlib on our device. But make sure you are connected to the internet and also you have a stable internet connection. So let's wait for a bit until this is done, and then we're also going to install Matplotlib. As you can see, pandas has been installed. I'm going to type in pip install matplotlib. Hit on enter and wait for a bit until it downloads all the necessary files, just like you can see right now. This is the exact reason why you need an internet connection, because sometimes there is a lot of data that is not given default by Python or the Python package. So just stay connected to the internet. And you can see everything is being downloaded. It is just going to take a couple of seconds. It is also going to install whatever is needed to make sure that Python and also to visualize your data, it is functioning properly. Wait for a bit and you will see it will also be successfully installed on your device. Now, another thing you have to keep in mind is to run and also test and also debug your program, which basically gives you out a test result. After this is done, the virtual environment is going to index again one more time, and it is going to update these skeletons so that whatever module or package you are using is functioning properly. Okay? As we can see, that is completely done. Now, let's create our CSV file first. So I'm going to name it student.csv. Okay? Ignore the extensions as we're going to be creating them right now. Let's say user, age, mark, or we can put in points, and also the sex. First off, Alan, age 18.88, and sex is male. Okay? Then I'm going to put in, let's say, Ron. Age is 17, point is 89, and also male. The next one is going to be, let's say, Nelly. Let's say 19. Point is 86. This person is a female. Then I'm going to put in, let's say, Henry. Let's say 19, 79. This person is a male. And then I'm going to put in Tara. So this person is 20. Let's say the point Tara got was 87. And obviously she's a male. So we have created our CSV file. Now, as we have our CSV file, we're going to take a bit of time to give you the introduction to EDA, which is Exploratory Data Analysis. Now you might think, what is it basically used for? So, EDA is basically used for understanding your data frame and your data set. Whenever you want to visualize your data or even create your module, you have to find out specific patterns of your data, how it is progressing, how it increases, or how it even decreases. And in your data set, obviously there could be a lot of missing values. Now those missing values are also known as outliers, and detecting them is the process of outliers. Whenever you are detecting the missing values and you are fixing them out or filling out with, let's say, replacing the data, so what you're doing through the process is preparing the data for machine learning or even for AI models. So to do all of those processes, the tools or the modules that we used are basically Pandas and also Matplotlib. Pandas basically validate your data, and Matplotlib basically helps you and serves the purpose of visualizing your data. So both of them, like together, gives you out basically the best type of outcome of getting your visualization of data. Now, let's create a Python file. Test. Here, I'm going to import pandas as PD. On the next one, I'm going to put in import matplotlib.pyplot as plt. Now we want to load our data set, which is CSV. df is equal pd.read_CSV. Open up the parentheses. Now I'm going to put in student.csv. Now I want to print out our data frame, but we want the first rows. Run the program, and it might appear up just like this. Okay? So, if you've checked out my previous classes, you already know what pd.read_csv does, which basically loads up your CSV file, and df.head basically shows you the first 5 or 6 rows in your dataset. So, this is basically the basic steps of EDA, which is looking through or going through your data. Now, what we're going to go through is going to be going through basic EDA, which is also known as dataset overview. So, over here, let's type in print. Let's say I want to get the shape of the dataset. To get the shape of the dataset, we put in df.shape. So, run the program, and there we go. We have 5. There we go, 5 columns. 5 rows and 4 columns. If you want to get out the exact column, what we basically do is type in print and then type in df.columns. Run the program, and it will only show you how the columns are shown. Okay? You can see syntax warning, return is finally a block. You can see this is how it works. And there we go. We have the columns. Now, what if you want to get out the info of the data? To get that, we type in print and then we put in df dot info. Run the program. In this way, you get the information or the whole information about your data set. Now you can also put in extra lines if you want to, but I just prefer typing it out just like this. If you want to get a whole summary of the statistics of your data set, we put in print df, and then we put in describe. Run the program. In this way, you get the whole summary, including the count, mean, standard, minimum 25, 50%, 75%, and also the maximum, which is 100%. So when you put in shape, it basically prints out the rows and columns, how many you have. When you try to get the info, it basically gives you out the data types, including the missing values info. And when you put in describe, it finds out the mean, mode, median, minimum, standard, and also percentiles. So this is basically the foundation of understanding your data set. Now, what if you want to handle your missing values? In my previous classes, I've already shown you how to, go through the process of handling the missing values. What you basically do is type in print, then put in df dot is null. That's it. Open up the parentheses. That's all you basically do. But if you want to sum it up, put in dot sum and open up the parentheses. In this way, it handles the missing values and also gives you a summation of how many missing values there is in the columns. So when you put in the function just like this, it basically does is that counts the missing values, and if the missing values exists, it basically shows it to you. What if you want to drop the missing values? We put in df drop na. So df equal df dot drop na. That's all. It removes the missing values. But what it does is removes the whole row. If you want to replace it with mean values, we put in df equal df dot fill na, open parentheses, df dot mean, and open parentheses. Run the program. In this way, it might show you off just like this, but here, what you can do is you can put in numeric only equal true. Run the program, and then it will work. If it shows you off an error over and over again, instead of fill na the whole thing, we put in fill na dot mean. There we go. In this way, this is how it is validated. So the drop na, what it does is removes the missing rows, but it can lose data. And if you put in fill na, it keeps the data and also gives you out in zeros or even NaN. Now what we can do is we can also cut this part out. It will still fill in the missing values. Now, what if you want to find some simple EDA analysis? Let's say I want to get the sex distribution. So I'm going to type in print df, and then here put in sex. After that, put in dot value. As you can see, we have a comma. I'm going to put in dot value, and then I'm going to put in counts and open the parentheses. Run the program, and you will see we have sex over here. I'm going to go over there, and we have this over here. So basically the value is the same. Okay? Even though it is showing you that it is not working properly and the method object is not subscriptable. So there is a specific value that is wrong within this. Okay? So after this, what I'm going to do is that we basically close this off we have value dot underscore counts. Okay, we have opened up the parentheses, and this is how it might show up as an error. But this basically works on the newest version of Python. So for the older syntax, there is a different method. First off, what I want to do is I want to print out the column to check if there is a column based on that. So here, print, here, df dot columns. Run the program, and first off, it will run the program. If nothing shows up like this, run it again, and you can see we have dot columns. So I'm going to check out if anything is working or not. If it ain't, then that means that we cannot find the exact column based on it. So let's check it out again, and you can see it is over here. User, age, points, and sex. So there is no null value on any of them. Okay? Now, another thing what we can do is we have this drop an A and fill an A. So we're going to cut out this part and run the program. If it shows you that it is now showing up on your screen, that it means that when you're putting drop an A and fill an A, it becomes a bit case sensitive, and also it drops the values. After this is done, you want to run the exact same code again, which is print df sex. After that, put in dot values or value underscore counts. Now you want to run the program one more time. There we go. We have 3 male and 2 female. What if we want to, let's say, get the average mark by, or let's say average points by the sex? So here I'm going to print out df dot group by. After that, let's say sex, and then we want to put in points. There we go. After points, I'm going to put in the dot mean value and run the program one more time. And there we go. For female, the average result is 86.5, and the average result for male is 85.3. So when you put in value underscore counts, it basically helps to understand the distribution. And when you put in group by, it finds the relationship between the columns and what you are trying to find. So we are basically done with EDA analysis. So now let's move into introduction to Matplotlib. So here I'm going to create a section, Matplotlib. So we're going to start off by visualizing your data. So just like I said, the main purpose of Matplotlib is to visualize your data. And there is a basic flow of Matplotlib, which are data preparation, plotting your data, giving labels to your data, and also representing it. So let's start off with it. Let's say I'm going to visualize the points of the students based on their names. Let's say I'm going to put in plt dot, let's say, figure. Now open up the parentheses. Let's say fig size. The size is going to be 6 by 4. Run the program, and you can see it is not working yet, because one thing over here is that whenever you are defining it, you have to make sure to put in a parentheses and also close it off. Run the program, and you will see that it might not show up just like this, but we have the name, the points, and the data types. Then here, close it off, and I'm going to put in plt dot plot. Here, first off, define the data frame. Now, first off, I'm going to put in the user or the name of the students. So I'm going to put in user. After that, put in comma, data frame, and then I'm going to find out the points. On the next line, I want to get the points of the user. So plt dot title, let's say points of the users. Now, in, let's say, a visualization chart, there's an x-axis and the y-axis. So plt dot x label. Let's say on the x label, I'm going to put in users. And on the y label, I'm going to find out the points. Now, I want to put in the x ticks. So plt dot x ticks rotation here equal, let's say, 46. And also, I'm going to put in plt dot show, which basically works like print. Run the program, and you will see something like this will appear up on your screen. We have Alan, we have Ron, we have Nelly. Let's also open that up. There we go. We have 88, and also Ron to be the highest score, which is 89. And this is basically how it works. Henry is somewhere like 79, which is like the lowest. And also, we have this Tara, which is close to 87. So, this is basically how it works. And when you put in plt, okay? So, basically this plt.show is for the line graph. And always, it shows the labels on the axis that you have put. On the x-axis, as you can see, we have the users. On the y-axis, we have the points. Okay? And also the rotation of the x labels, to make it readable, we put in 46. If you put in something like 50, that also works. Let's say I want to put in 50. Run the program or rerun it. And basically this is how it will look up. Okay? And you can also reduce it however you prefer. Let's say maybe I want 30. Run the program. And this is exactly how it will look like. Okay? If you reduce it less, let's say 20. Run the program. And that is exactly how it will work. There we go. So you can basically just customize it however you prefer. Now, even though this is the line chart, what if you want to get, let's say, a bar chart? If you want to get a bar chart, what you basically do, let's say, first off, I want to get the average points. Equal df dot group by. Open up the parentheses. First off, I want the sex based on the gender, which is over here. And then I'm going to put in the mean value. I'm going to put in plt dot bar, let's say average point, as you can see. And I'm going to start off with indexing. Now, after that, I'm going to find out the average points. But I'm going to put in average point again and put in dot values. After that, I'm going to put in plt dot title. The title is going to be average points by sex. Here, plt dot x label. First off, I'm going to put in the sex. Plt dot y label. and then I want the points. So obviously we put in plt.show at the end, and we run the program. You might see this is how it will look up, but what we want to do is we want to put in 3 of those. There we go. And then we can run the program. When we can run the program, we can cut this part out. We can put it over here too. Rerun it. And you might see this is how it might appear up, as there is an array problem. So we have both of them as sex over here. So here, I'm going to put in points. Run the program again and check it out. This is how it will look like. So basically, bar chart is very good for comparison. As you can see, just a bit, which was like 85 and also 80, or let's say 86 and 85. So it doesn't make any of that difference. Let's say points of run is going to be 65. Now if we rerun the whole thing, it will be a bit different. There we go. This is how it will look up. Okay? Now, even though we have this, let's say the next thing that we want to show is going to be the histogram. So if we put in plt.histogram, let's say df, and then I'm going to put in, let's say, points. Here I'm going to put in bins equal 5. And put in plt.title, double quotation, let's say distribution of points. I'm going to put in plt.xlabel and ylabel, the same thing. You have 6, and also on the ylabel, instead of points, let's say I'm going to put in frequency. And the last thing is obviously plt.show. Run the program, and it will just appear up in just a couple of seconds. There we go. We have frequency, and we also have the sex. So this is basically the best if you want to detect outliers and also for skews. Let's also cut this part out. Control X, Control V, and the last thing that I want to show you is going to be the scatter plot. So plt.scatter. Let's say df. First off, we want the age, comma, df. I also want the points. There we go. On the next line, I'm just going to basically copy these. There we go. Here, I'm going to put in age with points. Instead of that, I'm going to put in age and also points. PLT show, that's it. Run the program. And this is how it will look like. And this is called scatter plot, which is basically the best for correlation. Okay? So, that is going to be it for this class, and hope you understood about everything in this class. So, the final summary is, you have learned about what is EDA, why is it important, how you can load up and inspect your data set and your data frame, how you can get the shape of the data set, get the information, the description, detection, handling the missing values, grouping and summarizing the data, and also visualizing your data using Matplotlib in different type of formats such as bar chart, line plot, histogram, and even scatter plot. Okay? So thank you for watching this class up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data analytics.